In this video, we will discuss Venn diagrams. Okay, first of all, we will discuss the representation of Venn diagrams. So we need a rectangle over here, big rectangle. So over here we do have the X, or you may say as the universal set. Universal set. Or you may write it as this universal set, either X or this symbol represent your universal set. So inside this rectangle, we do have the subsets or the overlapping sets, all kind of sets involved in it that describe a relation with the universal set and the subsets of the set. All right, so this is simply the representation of Venn diagrams. So let's take some of the examples to discuss in detail how can we draw the Venn diagrams. Okay, in the Venn diagrams, this universal set, pupils in the class, C, pupils who like chocolate, and S, who like sweets. So these are the people. C is the people who like the chocolate, and 3 are the numbers that doesn't like chocolate or sweets. Okay, how many people like chocolates? So we have to, all right, so you have to see that they have written the members, total members, the number of members over here, not all of the members. Okay, they have, so these are the numbers of members. So we have to count that 4 and 12 also, because these two both like chocolates. But some of them, like 12, are the people that both like chocolates and sweets both. So that's always that they 12 plus 4 persons like chocolates. Okay, find number of S and express what this mean in words. All right. Number of S set 12 plus 2, 14. So 14 people that like sweets and chocolate both. So we'll express that in words that 14 are the people that like chocolates and sweets both. Okay, you just need to write that 12 other people that like chocolates and sweets both, and 2 other people that like only sweets. So that will be your description in words. Alright, C part, number of the N, number of the C intersection S. So in intersection, you know that we have to write only the common elements, common members of that set. So you already know that number of common elements are 12 over here. So this overlapping shows that. Alright, how many people are there in the class? So you have to total this all 3, 4, 12, and 2. This whole value gives you people in the class. Alright. Let's take another example. So universal set have all the alphabets, small alphabets, like starting from the A to J. And A have the elements A, C, E, G, I, N. These some of the elements are present in B set. Okay, show this information on a Venn diagram. So again, we have to use a rectangle over here, big rectangle. All right, so what we do need? All right, so is there any common elements? C and E. C and E are the common elements in both sets, so we will give the overlapping of the set. All right, C and E are the overlapping elements because they both are common in both of the A and B set. So other than common elements will be written over here. D and F. Alright. So A, B, C, D, E, F, G, H, I, and J. So in this way we'll describe our Venn diagram. This is A set and this is B set. And now you have the clear idea how can we represent a Venn diagram. Like we have focused on some common elements that are present in both sides. We overlap them and then write all of the rest of the elements other than common elements in their respective sets. And you already know that what's present inside it is also a member of this whole set, universal set also. So let's move towards our next part. List A in intersection B and find numbers of A intersection B. So that's pretty obvious. C and E. And the number of the intersection of these two sets is 2. Alright, let's do the C part. Thus, A intersection B is equal to B intersection C, B intersection A. Yeah, obviously. Yeah. Alright, B is a subset of A. No, B is not a subset of A because B doesn't contain all of the elements that are present in A. Subset is that contains all the elements. Like if it is in this form, we can say that B is a subset of A. But as you can see that we have some of the elements that are present in A too, but not all of these elements. So we'll simply write it as no. Okay, this is our last example. Highlighting Venn diagram. Okay, so universal set contains ice cream in Marco's restaurant. C, ice cream containing chocolate. N, ice cream containing nuts. 53 is the number. Alright, so we have to work out this. Number of C set, number of N set containing nuts and chocolate. Okay, copy and complete the Venn diagram. So what you need to do that, as you can see that number of C set is 53. So we have to cancel out this 53 with 21. So we'll get to know that how much elements, how much members, how much ice cream doesn't have both of nuts and chocolate. Only have the chocolate inside that. And when we do this, 36 minus 21, we will get to know about the ice cream that contains only the nuts. So these are the numbers. Okay, copy and complete the Venn diagram. We have completed the Venn diagram. How many ice creams contain chocolate but no nuts? 32. How many ice cream contain chocolate or nuts but not both? How many ice creams contain chocolates? 32. 15. We have to add up these two, that they have chocolates and nuts but not both. How many ice cream are there in the restaurant? We have to total these all together. 21, 15, and 67. We will get to know about all the ice cream that are present in the restaurant. I hope you get to know about the Venn diagrams, how to represent this